Good morning to all of you. Myself, Dr. Nafis Akhtar Farooqi, Assistant Professor, Department of CSC. My topic is a data-driven artificial intelligence system, and the topic is a backpropagation. So, basically the aim of the session is to student able to understand the backpropagation technique and implement onto the neural network. So, in this session is to be designed into the introduction, backpropagation, type of backpropagation, background, what is the background of the backpropagation, and the example and describing the net and gradient descent. And after the completion of the session, student can able to the defining the backpropagation and working steps and how to implement the backpropagation algorithm with the help of the examples. Okay. So, firstly I define the basic concepts and definitions. Basically, backpropagation algorithm is the fundamental building block for the neural network. It was first introduced in 1960. It is basically designed for the testing of error and reducing the error with the help of the backpropagation technique. In case of the data mining as well as in machine learning also, there is to be calculate the quickly and derivatives in neural network which change the output and tuning of the adjustment. So, the backpropagation is an algorithm used to train the neural network feed forward. It consists of two steps: forward propagation and backward propagation. For example, if we have to given some house, we have to purchase some house, and so that we have to given a square footage, number of bedrooms. On the basis of that, we have to predict our house price based on the different parameters. So, the backpropagation is used to adjust the weight of the network and to minimize the difference between the predicted price and the corrected price. On the basis of the backpropagation techniques, we have to divide the backpropagation network into the two types. First is a static backpropagation and second is a network recurrent backpropagation. What is a static backpropagation? That is basically that are basically used on the static classification problem, for example optical character recognition, and the recurrent backpropagation network, that is used for the fixed point learning. That means during the neural network the weights are numerical values that determine how much nodes referred as a neurons, means influence the output values. They adjusted so that network can achieve stability by reaching a fixed values. So, in this slide I am explaining the whole concept of the backpropagation network. What is a backpropagation? It is feeding the input data through the network, calculating the error, propagating the error back through the network using the chain rule, and calculate the gradient at each layer. Here, see here, this is the input and here is the cost function, and we have to take the partial derivative of each weights here in each and every steps, and this process is repeat multiple epochs to minimize the error and improve the network's performance. So, what is the background of the backpropagation? Means our aim is to training the process and find the weights and biases to minimize the error. It is done by gradient descent algorithm, means weight are randomly initialized to iterative process, because in each iteration we have to update our weights. For the updation of the weight, for forward pass there is to be current prediction and our actual output. There is a difference between them, and we have to calculate the cost function by cost j is equal to 1 by 2 y hat minus y ka whole square. That is calculated the cost function, and it will be continued here. The see here the negative gradient descent and positive gradient descent. Both of the values are coming after the updation of the weights. Okay. So, the algorithm is iteratively moved by step in the direction of a steepest descent towards the minimum point, and the step size is named as the learning rate, and this is a scalar quantity. So, our aim is to change the weight in each and every iteration for the quickly neural network convergences, and the learning rate is a hyperparameter that must be tuned. So every time we have to tune the network by using the learning parameter with the help of the gradient descent. And what is the weight update? The weight updates is a gradient are multiples by learning rate, and the new weights are calculated by the following formula. That means we have to calculate the partial derivatives of the errors by calculating the suppose the weight is a old weight is a W old, and the new weight is named as a W new, means W new is equal to W old minus alpha into del of J upon derivative of W, and this J is basically the error where we have to find the gradient descent value. It will be positive or negative, and the network learns by adjusting its weights and biases through the process of forward propagation, loss computation, back propagation, and parameters update using an optimization algorithm. So this is the step. First is a forward propagation, loss computation. After that we have to implement the back propagation. So in this way we have to update the weight, and there is two parameter is to be updated here, and we have to implement the concept with the help of this describing the neural network. And here is a 3-layer network architecture, where is the first is a input layer, that is a X, it will be denoted as a naught, and second is the hidden layer, that is denoted as a A1, and the Y hat it is a A2, that is the output layer. And in case of the forward propagation and cost function, we have to evaluate the Z1, that is a W1 x plus B1, means we have to perceive the backward propagation is calculated by with the help of their weights into multiplied by the weights plus their biases, and it will be gives the Z1, it will indicated that the layer numbers. Okay. Then the non-linear activation function is added here, and that non-linear function A is calculated by A of 1 is equal to 1 upon 1 plus e to the power minus z, and this computation is done on the first layer. And similarly the second computation on second layer, that is on hidden layer, that will be calculated as Z2, and A2 is calculated as, and the forward propagation and cost function is graphically represented as this, where we have to calculate the cost function, and this is the cost function where we have to find the error and reducing the error with the help of this formula. And in case of the back propagation in our 2-layer network, there is a 4 parameters, that is a W2, B2, W1, B1, and therefore 4 gradient is to be computed here, where J is the error where we have to reduce with respect to the W2 and B2 and W1 and B1 in each and every weight and biases, but our derivatives are the finding with the help of the chain rule. So how we have to implement the chain rule? The chain rule is implemented through this here. See, there is a del J upon W2, del J A2 and del Z2 and Z2. This is a chain rule where we have to implement, and the gradient of cost with respect to the weight of layer of 2 W2 is to be calculated here. Similarly, we can compute all the partial derivative and update the weights, and we get the full detail that I have already shared the link here. We have already taken as a reference for the finding the cost function. And there is a difference between the forward propagation and backward propagation. For what is a forward propagation? In the forward propagation, input is fed into the network in each layer, and there is a specific activation function between the layers, and there are weights that represent the connection strength to the neurons. The input runs through the individual layers of the network, which ultimately generates an output. In case of a backward propagation, it is a reverse of it. That means there is an error function measures how accurate the output of the network is. We have to improve the output, the weight must be optimized. The back propagation algorithm is used to determine how the individual weights must be adjusted. The weights are adjusted during the gradient descent method. And what is a gradient descent method? Basically, gradient descent method is an iterative optimization algorithm that are used in machine learning to minimize the loss function. The loss function is describe how well the model will perform in given current set of parameters, and gradient descent is used to find the best set of parameters that are achieved to partial derivative of at given point, and then iteratively traversing the search space in the negative direction of the function gradient. So, see here, this is the graph for the gradient descent, where we have to perform the action as the loss function, where we have to improve our loss function by the updating the weights, and which is the minimum the loss function is a proportion of the derivatives of the error. The two key aspects of gradient descents are the direction to move and the size of the steps. And the gradient descents have different types: mini batch gradient descent, stochastic gradient descent, batch gradient descent. Different types of gradient descents are used in our case. Basically, stochastic gradient descent are popularly used for optimization in the minimizing the loss function. This is used for solving the optimization problem by minimizing the function. And similarly, there is to be gradient descent is happen for the parameter is called the learning rate, which represents size steps taken that the network navigates the curve in search of the valley, and there overshoot the minimum. And if it is too low, that is the training is too long and may never reach the minimum, so we have to stuck in the local minima. So, in both of the figure, this is a big learning rate and this is a small learning rate, where we have to go on the high side, and here is a we have to go on the stuck position. And this is the step where we have to implement the neural network with the help of the backpropagation. Firstly, we have to collect the data set and define the neural network architecture, weight and biases initialization. Firstly, feed the training data through the network, adjust the weight biases with minimizing the error, and repeat the process in multiple times. And this process improves the network performance by minimizing the error between the predicted output and desired output. So, this is the step fulfill our the concept of the backpropagation. So, this is an example. Here the 3 layer and first input layer have a 2 input, and hidden layer have a 2 hidden layers, and output layer has a only one node. And our prediction is to finding the output as taken as the weights at W1 is equal to 0.11, W2 is equal to 0.21, and these are the weights, and these are the inputs 2 and 3, and our actual output, that is calculated by the activation function by the feed forward network. But in case of here backpropagation, that we have already discussed in the feed forward network by calculating the activation function, the actual output, and our aim is to predict the output. So, here the after the assigning the values and calculating by the forward pass, we have to gain the value is a 0.191. That is a not closer to the our actual output. So, we have to update the value by using the there is finding the error. Error is equal to 1/2 prediction minus actual whole square, that is a and here is a error is 0.327. So, again we have to reduce the error, means our aim is to reduce the error, and therefore, we have to decompose the prediction into the basic elements. We can find their weights are the variable elements affecting the prediction values, means we have to change the prediction value according to the weight values, means prediction is an output, that means 0.191, and here we have to break down the values till to change the prediction values. So, we have to need to change the weights here, means W1, W2, W3, W4, W5, W6, each and every weight is to be changed. So, how we can change or update the weight, and that should reduce the error. So, that is the answer is a backpropagation. So, here we have to take the partial derivatives of the weights and with respect of the error, and calculate the Wx, means every value is to be calculated by the derivative of error function and calculated by applying the chain rule, means W6 is calculated here. W6 is equal to W6 A into delta H2 W2 and similarly W5, W3, W4, each and every value is calculated here, means each and every weight is to be updated here, and we have to rewrite the update formula in the matrix format as here, and then we have to calculate the values and we have to take the learning rate. What is the learning rate? That is a what we have to take, and that is a guess number. Generally we have to take the 95% learning rate, 85% learning rate. According to that we have to calculate the learning rate. That is a learning rate is a hyperparameter, that is a need to manually guess its value. Okay. So we have to calculate here, and that after that the prediction value is applying the values are here 0.26, means we have to notice that the prediction is 0.26. it is a little bit closer to the actual output than the previously predicted one 0.191. we can repeat the same process of backward and forward pass until the error is closer to the equal to the 0. So our aim is to close to the error is equal to 0, and this is the way we have to calculate the back propagation. Okay. So if we want to visualize the forward backward propagation, I am giving the link here. You have to go on multiple times and calculate the back propagation value, that is a predicted value and actual value. Okay. So these are the terminal questions. Okay. Thank you.